Spring Boot is powerful, but most developers still fuck it up. They dive in, copy tutorials, and think it will magically scale. The reality is, even small mistakes can become performance killers, deployment nightmares, or debugging nightmares later on. First mistake, ignoring proper dependency management. Spring Boot makes it easy to add starters and libraries, but blindly pulling in everything bloats your app. More dependencies mean longer startup times, hidden conflicts, and headaches you will regret during maintenance. Second mistake, misunderstanding auto-configuration. Developers assume Spring Boot does everything perfectly out of the box. It does a lot, yes, but relying on defaults without knowing what is happening under the hood leads to subtle bugs that are hard to trace in production. Third mistake, not using profiles correctly. Many apps hard code configurations or use a single profile for dev, test, and production. This creates environment drift. You test locally, it works, but deploy it, and suddenly your database connection or API keys break silently. Fourth mistake, overcomplicating beans and component scanning. Spring Boot scans packages recursively, which is great until you accidentally scan too much. Extra beans, circular dependencies, and slow startup times appear, and tracing the source of the problem becomes exhausting. Fifth mistake, neglecting transaction management. Developers treat transactions casually or assume Spring handles everything automatically. Missing transactional boundaries can silently corrupt data. Wrap database updates carefully and know when propagation matters. Sixth mistake, ignoring caching. Spring Boot has excellent caching support, but devs often skip it or implement it poorly. Simple read-heavy endpoints without caching can become CPU and database bottlenecks under load, while properly configured caches cut response times dramatically. Seventh mistake, improper exception handling. Developers rely on default error pages or generic HTTP codes. That is fine for development, but in production, users and monitoring tools get zero context. Custom exceptions with clear responses are crucial for maintainable services. Eighth mistake, misusing Spring security. It is powerful but complex. Developers either leave endpoints wide open or oversecure everything. Misconfigured authentication, CSRF, or method security creates vulnerabilities or blocks legitimate users, both of which are costly mistakes. Ninth mistake, ignoring actuator and monitoring. Spring Boot comes with built-in health checks, metrics, and endpoints, but most teams disable or underutilize them. Without proper observability, you cannot detect performance regressions, memory leaks, or failing integrations in real time. 10th mistake, failing to leverage asynchronous processing. Developers make everything synchronous, slowing down APIs and wasting resources. Proper use of async, task executors, or message queues allows scaling without massive architectural changes. 11th mistake, neglecting proper logging and structured output. Default logging is okay for small apps, but in real services, unstructured logs, missing correlation IDs, or excessive console output make debugging distributed systems nearly impossible. 12th mistake, underestimating testing. Spring Boot makes testing easier, but skipping integration or context-aware tests is a trap. Unit tests alone cannot catch configuration issues, bean loading problems, or transactional misbehaviors that only appear when the app runs end-to-end. 13th mistake, assuming embedded servers are enough. The default Tomcat or Jetty is convenient, but ignoring server tuning, connection pools, or graceful shutdowns can turn minor traffic spikes into total service failure. Know your server settings. Avoiding these mistakes does not require hacks. It requires awareness, discipline, and understanding what Spring Boot does under the hood. Mastering these areas separates a developer who copies tutorials from one who builds resilient, maintainable, and scalable real-world services.